only place that I see you possibly messing up is where it asks you to write it in standard form, okay? So notice at the top, they do give you vertex form, standard form, and factored form. That can help you if you're confused with what form I'm asking you for or what form you have. The first one says graph the function f of x equals 3 times x plus 2 squared minus 7, and it says describe the transformations. And so let's talk about left to right. Let's talk about the 3 first. What does that do? Vertical stretch by 3. All right, left to right. Next is 2. What does that do? Left 2. And then you've got minus 7. What does that do? Down 7. So we're going to start there. And so if I take my original vertex of 0, 0, it's not going to stretch, but it is going to move to the left 2 and down 7. Since that was my parent function vertex, that's now my vertex of this function. So let's write down the vertex of negative 2, negative 7. And that means that my axis of symmetry is what? X equals negative 2. Don't forget the x equals because you're actually giving me the equation of that line. If you'd like to graph that line, that's fine, but it needs to be dashed and it needs to be labeled so that I know that you know that it's not really there. It's invisible. You don't normally see it. If you typed this into some kind of graphing software, you wouldn't see the axis of symmetry there. It does help us graph our points though. If I transform 1, 1, so I usually start at 1, 1, vertical stretch by 3 will put me at 1, 3. Left 2 will put me at negative 1, 3. And then down 7 will put me at negative 1 and then negative 4, yes? So negative 1, negative 4. And then that's 1 unit away from the axis of symmetry, so I can reflect that on the other side at negative 3, negative 4. The parent function. X squared. 0, 0, 1, 1, 2, 4. That's a good question. And so remember, this is a parent function. And so if you think about y equals x squared, that has a vertex at 0, 0. Next point is 1, 1. Next point is 2, 4. Those are the points that I'm transforming. And so from 2, 4, vertical stretch by 3, where's that going to go? So vertical stretch by 3, yep, that happens to the y, so that's going to be 2, 12. And then I've got left 2 on the x. Where's that going? 0, 12. If it goes off the graph, I usually write it down. And then down 7, where's that going? 0, 5. Hey, what else is that? Yeah, it's the y-intercept. That's 2 units away from your axis of symmetry, so you can go 2 more on the other side and graph its reflection point. Those reflection points get you out of graphing, or get you out of transforming the like negative 1, 1 and negative 2, 4. So try to do the reflection points. There's our nice parabola. It shouldn't be a V shape. It should be a U shape, a curve. And we did find the y-intercept to be 0, 5. So if you graph that as you're going, you might as well just write it down. What's the domain? Negative infinity to infinity. What else could you write? All real numbers, that would be fine too. So range is which variable? The y. What's the smallest y we can have? Negative 7. Do I want to include that? Yes, because I have a vertex there. So bracket negative 7, comma what? Infinity. It goes up forever and ever. You can't include infinity, and so it gets a parentheses. Anybody get all those parts right, including the graph? Nice. We remember some stuff from Algebra 1. As long as, so the question was, is the parent function always x squared? As long as your function's being squared. Yes. Now, if it had like the bars, what would your parent function be? What's the bars? Absolute value. So that would be your parent function for absolute value. So it just depends on what your function looks like. But if it's a squared, it's going to be x squared. The bars? It'd be vertex of 0, 0 opens up with a slope of 1 and negative 1. The V shape? Okay, we're not going to go down that rabbit hole. All right, now we got to rewrite in standard form. What do we know about standard form for a quadratic? Ax squared plus b. Oh wait, you said ax plus by equals c. What kind of function is that? A linear function. We want standard form for quadratics. Where'd you get that? Yeah, the top of your paper. It's right there. Okay. What does standard form not have that our function has? Okay, yes. Even more simple than that. Ooh, the f of x is its name. We're going to keep f of x. What else does it have that standard form doesn't have? It does have an exponent. It's just in a different place. Parentheses. Yeah. So that tells me I got to get rid of my parentheses if I want it in standard form. Why are the parentheses there? Ooh, because we're going to have to distribute what? We're going to have to, no, we're going to have to distribute the 3. The square means what? The what? What? There's 2 of them. So that means the x plus 2 is doing what? If it's squared. Multiplying it by itself. So we've got f of x equals, please keep its name on there. Its name is Fred. Please keep his name on there. Equals 3. We're not going to distribute 3 yet. We're going to write 2 copies of x plus 2 because that's what the squared is telling me to do. Remember, you do exponents before you do multiplication? Yeah? And then minus 7. From here, let's multiply our binomial times our binomial first. So f of x equals 3 is going to stay. And then open a parentheses. X times x is what? Just x squared. X times 2 is 2x. How many times are you going to do that? Twice. 1 for the outside, 1 for the inside, right? So if it's 2x and 2x, that makes 4x. And then the last would be 2 times 2, which is 4. Close it, and then you still have minus 7. Do we see how we can't, I'm going to do this in red because we can't do this, we can't just distribute our power here? Do we see how x plus 2 squared is not the same thing as x squared plus 4? Because it's actually this thing. Do we see that? Yeah. When you multiply a binomial, when you square a binomial, you're going to have a binomial times binomial, which gives you 4 terms. If you just square each of them, you still just have 2 terms, and you forgot about 2 of them. So please don't do this part. No, please. Sad face. Ah! Okay, please don't do that part. All right. Expand it. Make sure there's 2 copies of it. And then keep going. Now we can distribute our 3. So f of x equals 3 times x squared is just 3x squared. What's 3 times 4x? 12x. So that's plus 12x. And what's 3 times 4? 12. So plus 12. And we still have minus 7. That minus 7 should tell you what to do next. What do you have to do next? Yeah, combine like terms in that 12 and that negative 7 to be what? 5. Didn't we have a 5 somewhere else? Where? Oh, the y-intercept. The y-intercept happens when x is 0. Notice, every other term in standard form has an x, right? What's going to happen to those terms if I make x 0? If I plug in a 0 here and I plug in a 0 here, they're going to go away, right? They're going to be 0, and it's going to leave you with what? 5. So standard form, this constant on the end should always match your y-intercept every single time. So you have a little self-check there. What questions do we have? Do you want to do the next one on your own, or do you want to do it together? Did most of you already do it? You did the transformations? Okay. We'll do it together. Is everybody ready to move on? Scream if you're not. All right, what's the negative do in the front? Reflection over the x, okay? 2. Vertical stretch by 2. Minus 3. Right 3. Plus 8. Up 8. If I'm transforming 0, 0, 0, 0 does not get reflected, and it doesn't get stretched. So it's just going to move to the right 3 and down 8. That's my new vertex because 0, 0 was the vertex of my parent function. So my new vertex is 3. Oh, I went down 8. I should go up 8. Boop, boop. Sorry. 3, 8. And I'm going to graph my axis of symmetry on there as well, just to help me later. And that's going to be x equals 3. What's my next point I can transform? 1, 1. So if I start at 1, 1, reflection over the x puts me at 1, negative 1. Vertical stretch by 2 gets me 1, negative 2. And then right 3 will hop over the axis of symmetry to 4, negative 2. And then up 8 will put me at 4, 6. That is 1 unit away from my axis of symmetry, so I can go 1 unit on the other side and graph its reflection point. What's my next point I can transform? 2, 4. And so 2, 4, reflection over the x goes 2, negative 4. Vertical stretch by 2 will put me at 2, negative 8. Right 3 will put me at 5, negative 8. And then up 8 puts me at 5, 0. That's 2 units away from my axis of symmetry, so I can hop over 2 more and graph that point. Is there another one I can graph? What's the next point I would transform? 3, 9. If I reflect that over the x, it's going to go 3, negative 9, right? What's going to happen when I do a vertical stretch times 2? Be 3, negative 18. That's off my graph. What if I move that to the right 3? 6, negative 18. Okay. And then last, what if I move that up 8? 6, negative 10. I can graph that one. So 6, negative 10. What's the reflection point? Well, to the left, how many? And then 3 more, right? What would that be? That's your y-intercept. What is it? Close? 0, negative 10. It's an intercept, so you have to give me an ordered pair. And then that gives my nice parabola. Boop-a-doop-a-doop. What's the domain? Negative infinity to infinity. Give me something shorter because I don't have a lot of room. All real numbers. Range? Comma 8. What's the notation? Parentheses, bracket. Awesome. Do we have questions on the graph? Pretty okay? Write it in standard form. First thing we have to do is expand it. So g of x equals negative 2. There's going to be x minus 3 times itself. So x minus 3 plus 8. Multiply your two binomials first, then distribute the negative 2. So I've got g of x equals negative 2 times x is x squared. I've got an x times the negative 3, and then I've got a negative 3 times x. So I'm doing that 2 times. What's negative 3 minus 3? Negative 6, and that's going to be x. And then negative 3 times negative 3 will give me positive 9. Close it, I still have the plus 8. You can't add the 9 and the 8 here because the 9's being multiplied by negative 2 first. So you got to distribute your negative 2. So g of x equals negative 2 times x squared is negative 2x squared. Negative 2 times negative 6x is a positive 12x. And negative 2 times positive 9 is negative 18 plus 8. Yep, your last step is to combine your constants. Negative 18 plus 8 will give you negative 10. How do I know that's correct? That's my y-intercept. So negative 2x plus 12 minus 10. And remember, your negative 10 should match this negative 10. When you're ready, let's finish note set 3. All right, we're going to finish up sum and difference of cubes today. These 5 examples are pretty much, it encompasses pretty much anything you'll see across sum and difference of cubes. Make sure you're doing your homework. There's a ton of practice on this on your homework, but these, we don't really have an I do, you do with these because they're pretty much all different. Hopefully you'll get the hang of it by the end. With number 13, remember with sum and difference of cubes, we want to say what's being cubed first. And so for this one, we've got something being cubed minus something being cubed. And the first one is x to the 3n, so I know it's going to be x to some power. And power to a power is what? Close. Multiplying. So what would I multiply 3 by to get 3n? 1 what? N. Just So x to the n is being cubed there. What's being cubed to get y to the 3n? Y to the n. So then, first one, the binomial is just going to be your first term here, x to the n. Same sign as your problem, minus. And then this term, y to the n. Your trinomial is going to start by taking x to the n and squaring it. What's x to the n squared? X to the 2n. Your first sign was the same. This one is opposite, so plus. And then your middle term comes from multiplying x to the n times y to the n, which is really just going to be x to the n, y to the n. Same opposite, always positive. And then your last term is going to come from y to the n squared. What do I get there? Y to the 2n. Done. That's your answer. Questions on 13. My biggest advice is just make sure you take out a GCF first and then look at what's being cubed to get each term. So in number 14, what should I do first? Yeah, I'm going to have to take a GCF because I've got fractions. I know I'm going to have a denominator of 4. Can I take anything from 3 and 81? Do they have a common factor? Are you sure? What's 8 plus 1? 9. Is that divisible by 3? Then so is 81. So are you sure you can't take anything? Don't 3 and 81 share 3? So you have to take that. So we actually need to take a 3/4 here. And I can't take any variables. So 3/4 times x to the 9n is going to give me 3/4 x to the 9n. Plus 3 times what gives you 81? Bless you. 27, good. And we have the 4th on the outside, and then we have y to the 3m. This is really the same as 3/4. I'm going to use a bracket for right now because I'm going to have more parentheses on the inside. Something is being cubed here, plus something is being cubed here. What's being cubed to give me x to the 9n? X to the 3n. Remember, you're multiplying your powers there. 3n times 3 gives you that 9n. What's being cubed to give me 27? 3. What's being cubed to give me y to the 3m? Y to the m. Good. Now here, you're just gonna have 3/4 times your binomial times your trinomial. So at this step, if you want to drop the brackets, you can. The brackets were really just there for me to see what I'm cubing. So 3/4 times my first term that's being cubed is x to the 3n. Same sign, plus my next term that's being cubed was 3y to the m, and then that's my binomial. My trinomial will start with x to the 3n squared. What will that give me? X to the 6n. My sign, same opposite, will be minus. And then when I multiply my two terms that are being cubed together, x to the 3n times 3 to the ym is going to be 3 x to the 3n y to the m. And then always positive. What do I get when I square 3y to the m? You're squaring 3 as well. 9y to the 2m. That's it. What questions do we have? Make sure you're trying your homework. It's easy to watch me do it, and it's easy when I walk you through it, which is what I'm supposed to do when we do guided notes. It's going to be harder for you to do these on your own. So make sure you're practicing this before Friday by doing your homework. This last one, what do you notice? Fractions and the exponent. So I'm going to have to take my smallest exponent, right? What's my smallest exponent? the 2/3. So I'm going to have to take that as a GCF. There we go. I'm going to have to take x to the 2/3 as a GCF. Is there anything else that I can take? 6. 6x to the 2/3 times what will give me 6x to the 2/3? 1. Some of you are forgetting to put that 1. You need to put the 1. And then 6 times what gives me 48? 8. And x to the 2/3 times x to some power is going to give me x to the 11/3. What are you doing with your powers there? Adding them. What do you add to 2/3 to get 11/3? 9/3 or 3. So this is 6x to the 2/3 times something being cubed plus something being cubed. What cubes to get 1? 1. What do we raise to the power of 3 to get 8x to the 3rd? 2x. I don't know if I'll be able to write this here, but we're going to try. So I've got 6x to the 2/3 times my first term. I really should turn this around because the 2x should go in the front, shouldn't it? Tell me why I'm mathematically allowed to turn this around. Addition, so 1 cubed plus 2x cubed is adding, and addition is commutative. So I'm going to put my 2x first, and then my plus 1. And 2x squared, you're squaring the 2 and the x, that'll be 4x squared. And then same opposite would be minus 2x times 1 is 2x. And then 1 squared will give me a plus 1, always positive. If you wrote it the other way, you'll notice that it's just turned around. Your signs are all going to be the same, so that's fine. I turned it around because your x typically needs to go in the front. So if you didn't turn it around, it should be still equivalent because your signs are the same. That wouldn't be true if one of your 4x squared or your 2x in the front here was negative, then that would absolutely have to be factored out. But it's fine if you didn't turn it around for this one. What questions do we have? We're almost done. How many examples we got? 2? The last one's easier than the other one. The next one, the next one's interesting. What are we going to use on the next one? Substitution. I've been getting a lot of homework questions like this, like, oh my goodness, what do I do with this? Substitution. You've got a binomial on the inside, so let's make a equal x plus 3, and let's make b equal x minus 4. So then if I were to rewrite this, what would it say? A cubed minus b cubed, and that's a difference of cubes, right? Yeah? So we can factor it. A, same sign, minus b times a squared. Opposite sign would be plus ab, and then always positive b squared. Once you factor it, so we're done factoring this, you can plug a and b back in. With this, you don't need to have parentheses around x plus 3 and x minus 4 until we get to the trinomial. Then you'll need them. But the binomial in the front, we don't need them. So a is x plus 3 minus, you're subtracting all of b. So you're subtracting an x, and you're subtracting a negative 4. What's subtracting a negative 4 going to look like? Plus 4. Now I'm going to use a bracket because I told you you're going to have to put parentheses around a and b. A is being squared, so x plus 3 is being squared. Plus, a and b are multiplying, so you're going to have x plus 3 times x minus 4. Plus, b is being squared, so you've got x minus 4 squared. Y'all want to know the good news? I asked Miss Tate about this one because I was like, whoa, like this one's gnarly, like this one's crazy. And she said in the next step you can stop. So she saved your life today. What's going to happen with the front? What's going to happen with x plus 3 minus x plus 4? The x's are going to make 0, right? What's 3 plus 4? 7. So this is 7 bracket x plus 3 squared plus x plus 3 times x minus 4 plus x minus 4 squared bracket. And we're going to stop there for that one. I started expanding it and it was crazy. What questions do you have? This last one's pretty easy, but it's pretty easy if you know your cubes. But there's some notation differences, so make sure you don't tune out because it is kind of weird. The notation's kind of weird. Are we ready to move on? All right, so what's being cubed in our first term? Sine, and then what's being cubed? Sine of x, and then what's being cubed in our second term? Cosine of x. We don't really have to use substitution here because it's not sine plus something, and it's not cosine minus something. It's just sine and cosine, so it's going to be fine. Our first binomial is going to be sine of x, same sign, minus cosine of x. This is where the notation gets a little weird. Sign, so sine squared x, and then opposite would be plus. We're multiplying sine of x and cosine of x, and then always positive, we're going to be squaring cosine, which looks kind of the same as squaring sine, except it squeezes between the cosine and the x. Make sure you write that correctly. If you write it incorrectly, unfortunately I have to count that wrong because it's not the correct notation. Questions, comments, concerns? That's where you stop on that one. So that one's finished. Hey, nice job. You got a little over 10 minutes to work on your homework. Yeah. No Math Excel until after fall break. You do have homework tonight and you do have homework tomorrow night. So let's make sure we're working on it and asking me questions on it. No. Where did it go?